Okay. So we go to the data representation. Okay. The first, it's a decimal and binary representation. So this one actually you're not right on the class because they changed it to the new format. So this is a slide I got it from my old class here, but I think it's somehow it's better to help you to understand with the requirement of this module. So the first thing we'll talk about the decimal and the binary representation. Right? It's a number. Normally, the number you use nowadays, you use on every day. It's a decimal system. So decimal, what is decimal? Decimal that means you have the 10. Decimal that means 10 here. Right? For the digit, you have the you have number. You have the 10 digit. You have everything from 0 to 9. Right? Every 0 to 9, you have 10 digit. For every number, you have for every digit, you have the 10 value, everything from 0 to 9. Right? That's why it uses 10 as a base here. But actually, the number system can be any base. Any base. It can be the by 2, by 3, by 4, by 5, or 8, or 16, whatever. Right? Computer, it works with the binary system. Binary, that means 2 here. That is by 2. By 2, that means for each number, you only have the 2 value. Remember, for binary, you will only have 1 and 0. That is binary. Right? Decimal, you have everything from 0 to 9. You have 10 by 10. But for the computer, for binary, you have by 2 because you only have a 0, 1. Right? And some of the other computer, you can use the octal. It is a base 8 or hexadecimal. Hexa, you have the 16 here. It's a base 16. Okay, so now let's work with how we're working with the representation. Okay, now. Okay, so we talk about base and exponent. So if you put something in the format, if you say put something is here in the formula here, you have this one is the base, and this one is the exponent here. So we see this one is 10 raised to power 2. 10 here is the base, and 2 here is the exponent. So we have the 10 raised to power 2. That means you 10 times 10. It's 2 times. I have 100 here, and you have the 5 raised to the power 6. That means you have 5 times 5 times 5 times 5, 6 times. You have this value here, right? So you have one exception here. You have actually you have 2 exceptions. The first one, whenever you have non-zero number, when you raise to the power 0, the result is always number 1. You see what number it is, whatever number it is, whatever number it is. When you raise to 0, you always have number 1 if they are non-zero number. And you have 0 raised to power 0, it's undefined. Right? That is the 2 rule. That are the 2 rules you have to remember. The first one, whatever number it is, if they are non-zero number, when raised to the power 0, you have number 1. And the second one, you have 0 raised to power 0, it is undefined here. Okay. Okay, so I have a very, very quick question here. So do we think that any of you will plan to go to the campus on Thursday evening or not? Let me know.
I won't.
Any of you want to go to the campus on Thursday? Hello?
I'm not no.
All right. Because the thing that if you don't go to the campus here, I can work from home. I can show the Zoom meeting here and I work in my server. It actually is the same. I don't have to go to the campus here.
That's fine with me.
How about any of you, if you plan to the campus, let me know. I will go to campus if you want. If all of you stay at home, I can stay at home. Okay, so I am making in the announcement. Okay, that is okay. So now we move to the decimal system. Remember, decimal system is the by 10. The by 10. Each number you have the 10 possibility here. Everything from 0 to 9. And if we look on the decimal system, you have the column position also, right? So this one it is column 1. This one is column 10. This one 100,000, 10,000, 100,000, million, and 10 million. And the reason is you have one because this one you have the 10 raised to power of 1. Sorry, raised to power of 0. You have 1 here, right? And this one is a 10 because the 10 raised to power of 1. You have 10. And this one you have the 10 raised to power of 2. You have 100 and 1,000 and so on. So basically, if you have the number 5,863 here, actually you have to break it down in the column value here, right? So what is the 5? Actually, you have the 5 times 1,000 here. Right? 8 here, you have 8 times 100 here. And for 6, you have 6 times 10 here. And for 3, you have 3 here. So when you add them up together, right? When you add them up together, you have 5,863 here. That is a decimal system. And this value here, they are column value here. They are column value. The same working exactly the same with the binary. Exactly the same with the binary here. The only difference is that in the binary, it's by 2. Right? It's by 2 here. It's not by 10. So that's why when you power to the column value here, the first one is raised to the 2 raised to 0, and the second one you have raised to the 1, and the next one you have raised to 2, raised to 3, and so on. Right? The same. The syntax is the same. Okay, so now you see it work exactly the same here. Okay, so now see, that is a binary system, right? That is a binary system. So we see this column here, you have the base 2 raised to 0, you have 1. This one, base 2 raised to 1, you have 2. This one, base 2 raised to 2, you have 4. Double it, you have 8, 16, 32, 64, and 138 here. If you have 1 byte, you have 8 bits. Right? So that's why you have everything from 0 to 7 here. It is a 1 byte. That is everything. So here's the thing. If you have the binary representation here, saying about we have 0, 1, 1, 1, 0, 1, 0, 1 here. So the way you convert it to decimal is very simple. Right? You see, this one here, actually this one is 128, so we have 128 here. This one 0 of 64, you have 0. This one 1 of 32, you have 32. This one 1 of 16, you have 16. This one 0. This one here 4, this one have 0, and they have 1. Right? And now you add them up together. Add them up together. Right? Sorry, this one 32 here. Add them up together. So for this one, you have 160 here, you have 176 here, you have 180, and you have 181. This one you have 181. That is the way you convert from the binary to the decimal. You got it or not? Let me know.
Yeah.
Very simple, right? So now think about this one. Let me give you another example here. So if I have 0, you have 1, you have 1, you have 1, 0, 0, 0, and 1 here. So what do you think? What is the decimal number for this one? If you have 0, 1, 1, 1, 0, 0, 0, 1, what is the decimal here?
Let's see, it's going to be 103.
103, right? 103. Okay, this
Yeah.
one is no, not right. This one is already 96. Okay, this one is 112 and 113, not 103. 113 here. Right?
Yeah, you're right. Yeah.
Okay, so that is the way you convert from the binary to the decimal. Now, think about in the case I want to convert from decimal to binary. I want to convert from the decimal. Think about I have the number 201 here. Okay, so how it works? If you want to convert from the decimal to binary, you only have to run it everything from the left to the right. Left to the right. So see, 201 here is greater than 128, right? So you need 128 to make it up for the 201 here. So we have put number 1. Right? So you see, you already have the 1 of 128 here. You minus it. You minus 128 here. You minus 128, so you have 73 left, right? You have the 73 left. you move to the left. In order to make up for the 73, you need 64, right? Now you need the 64. So you minus 64, you have the 9 left. This one, you don't need it, 0. This one, 9 less than, you put 0. 9 greater than 8, you put number 1 here, right? So minus 8, you only have 1 left. Not this one, not this one, this one. Right? So we have 1, 1, 0, 0, 1, 0, 0, 1. It is a 200, sorry, 201 here. That is the way you convert from the decimal to the binary. Remember that? You always have to working from the left to the right. Right? If the number greater than something here, you put number 1. If number less than, you put number 0 here. Okay? Now, here's the thing. Is it clear to you? Let me know.
Yeah, I actually took this class with you last year, routing and switching.
Oh, really?
I did last year, yeah.
Routing and switching, the next 105?
Yep.
Okay, I remember you, Stephen. Okay.
Yeah.
Okay. So here's the thing. If you have if you have 1 byte, that means you have 8 bits, right? 8 bits here. So the maximum value is everything 1 here. Everything 1. Everything number 1. So when you convert it, you have 255 here. The minimum is everything 0. When you convert it, you have 0 here. Right? That's why for the 8 byte, the minimum value is 0 and the maximum is the value is 255. So if you want to convert something is 300 here, you cannot use 8 bit here. Right? 8 bits is not enough. That's why in that case, if you want to store the 300 into 8 bit here, you have overflow. That means you cannot store it here. That is the case that they call it overflow. Okay, so here is the way you convert from the binary to decimal and convert from the decimal to binary. Done it, right? Done it by everything here. Now, we move to the hexadecimal system. Hexa, that means you have 16 here. You have the hexa, that means you have the 16. So for each digit, you have the 16 possibility. Everything from 0 to 9. And after that, you have A, you have B, you have C, you have D, E, and F here. A, that means you have 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So if you have everything from 0 to 15, you have the 16 value and 16 possibility, right? So the way it works, totally the same. The only difference is the base now is not 10, base now is not 2, base now is 16. That's all. Base now is 16 here. All right. So now see how it works. Okay. So now we see. This one is a hexadecimal. All right. So we have the first column. By 16 raised to 0, you have 1. The second one, you have 16 raised to 1, you have 16. The third one, you have 16 raised to 2, that means 16 times 16, you have 256. The third one, so the fourth one, you have the 16 times 16 times 16, you have 4096, and so on here. Right? Now here's the thing. If I want to convert the number, C2 here, C2 here to the decimal. So what do you think? What is the number of C2 in the decimal?
12.
C is 12, right?
Yeah.
C 12, but Z is in the column of 16. That's why you have to time 12 to 16 here. That's the value of this one. Not 12 only. You have to time to 16 here, right? And you plug it to 2. That's all. That's the way you convert it, right? So you have the 16, you have the 32, you have 192, you have 194 for this one. Right? This one you have 194. So C2, when you convert it to the decimal, you have 192, sorry, 194 for this one. It makes sense?
Yep, makes sense.
Okay. It's the same. If you want to convert, sorry, what is it? Okay, the same. If you want to convert the decimal to the hexa also, you do the same. Now, if we say wow, is this one. If you want to convert the 875 from the decimal to the hexa, you only have to do from the left to the right. You only have to do the left to right. So see, for 875, that's done. That's why you have nothing here, 0, right? So now we move to the second one. You have 875. You need 3 times of 7. Sorry, you need 3 times of 256 to make it up for the 75, right? That's why you have 3 here. And you have a 3 here. So when you have 3, you time it to 56 in time 3. What do you got? 256. You have 8 here, carry on 1. You have 6 here, carry on 1, and you have the 7 here, right? So now you already have the 76 for this one. Now 76 for this one. So you minus this one. You minus this one to 768 here. Sorry, you have minus this one to 768. What you have left? You have the 107 here. You have 107 left. Now you have 107 left. You move to the next one. You move to the right. You see, in order to make up for 107, you need 6 times of 96 here. So this one you have 96. Now you have 96. And the last one, you have what you have. You have 11 here left. 11, that means you have B here. Right? So that's why when you convert from 875 to the hexadecimal, you have the 36B here. Is that okay? Do you think it's okay with this one? Actually, I think that right now, normally you don't have to do it. You just go to calculator. Right? Let me show you how to do it here. You go to calculator. And you're working with program here, programmer, right? So now if you want to convert it to 800, what is it? 75. I see this one is 875 and hexadecimal here. You have the 36B. You don't have normally you don't know how to do it, but normally you don't have to do it. You just use a calculator and you work in the programmer function and to convert it here. Okay, gone here. How we convert it from the hexadecimal to the decimal, right? You have 1 time of 4096. You have 2 times of 256, 3 times of 16, and this one it is 13, right? 13, and you add them up together, you have the 4069 here. Okay, now they're using the hexadecimal notation. Normally, you know that for 1 hexadigit, you have the 16 possibility, right? For 1 hexadigit, you have the 16 value. And in order to represent 16 value, you need the 4-bit record. You see, you have the formula here. Right? You have 2 raised to 4 is the 16. That's why in order to present 1 hexadigit, you need the 4-bit. You see, everything from 0 and everything go to 1 here. So everything 0, you have the 0. And everything is 1, you have F here. Sorry, you have F as 15 here. Right? And normally they group every 4-bit together to make it up for the hexadecimal notation. Right? Remember that. Okay, so here's the hexadecimal notation. If you want to convert the serial of the binary to a hexadecimal notation, you just group every 4-bit together. Remember, you group it from the right to the left. You just group it everything from the right to the left here. So you see, you group this one 4 bits, you group this one 4 bits, you group this one 4 bits, and you group this one 4 bit here. So we convert this one. Everything number 1. This one is the F here. This one is F, and this one 0. Of course, everyone is 0. Right? And this one, when you convert, this one is 8 and 10. So we have a 10, you have 8, you have 8. And this one we convert, you have 8 here, 4 here, 2 here. When you add them up together, you have 14. Right? So that's why you have E here. Remember when you using the hexa notation, hexadecimal notation, use the group every 4 bits together from the right to the left. So we think about in the case, I have 1 0 1 1 0 1 1 1 0 0 1 here. So what do you think? What is the hexadecimal notation for this one? What do you think? What is hexadecimal notation? Okay. Remember, you have to group every 4 bits together, but from the right to the left, right? So we have to group this one here. You have to group this one here, and this one is not enough of the 4 bit. You just insert the number 0 before that to make it up for the 4 bit here. So this again, this one you see, this one the 8, and this one 1. You have 9 for this one. This one 8, this one 2 is 10, and 11. That's why you have B for this one. This one you have the 1 here, 4 here, you have 5. So when convert this one, you have the 5 B9 here. Okay, now you move the integer representation. So the whole computer process the number depend on each number type. It depends, right? So it can be the integer number, or it can be floating point. Integer number, everything is a whole number. It's a whole number. Right? So you can think about this one here. You have -4. It's an integer number because it's a whole number. You have the 5. It also integer number. Floating point is a number. You have the float of the whole number and the flotation here. I think about you have the 4.5, right? And 4.57. It is a floating point because you have it's a whole number and you have a flotation portion of them. Right? Remember one thing here. If you have 4.0, it is also floating point. It's not an integer number. Even that is the same with the 4, but this one still have the whole number and the floating point here. Okay. And integer are stored and processed in the quite different manner from the floating point. The way the computer store the integer and the floating point number is not the same. And even with the broad category of integer floating point number, there are more distinction. It can be stored the unsigned number. So for the integer here, it can be stored unsigned number. What is unsigned? Unsigned is a non-negative. Everything 0, everything from 0, 1, 2, 3, and so on. Unsigned that means you cannot have the negative number here. Or it can be the single, or it can be the sign number. It can be for the size. It can be the positive, can be negative, and 0 here. Right? And floating point number, you have several variations also. Okay, now the first thing is unsigned integer format. Unsigned integer. Remember that unsigned integer is everything non-negative. Right? It can be 0, 1, 2, 3, 4, 5. Right? The computer process the information is from the byte. Bytes normally is 8 to the 16 bit here. Right? So 1 byte you have 8 bit, 2 byte have 16, 3 byte have 34, 4 byte have 32. Right? Now see, you only have to store it in the multiple 8 bit here. It's 1 byte, right? So see, in order to store 1 here, in order to store, sorry. So in order to store 11 and 101100, they have the same length because you have to make it up to the 8 bit here, right? So in order to do that, you have to adding 0 to the left of the number to make it up for 1 byte. I think for this one, you only have a 2 digit here, right? So to store it into 1 byte of 8 bit here, you have to insert 1 1 0 0 0 0 0 0 0 here. You have to insert 6 0 on the left to make it up for the 1 byte or 8 bit here. The same as this one. You have 1 2 3 4 5 6, right? You have to insert 0 0 here to make it up to the 8 bit here. Okay. And this is called the unsigned form of the integer. This one you don't have you cannot use for the negative number. Only everything is a whole number. It's a non-negative format. So when working the side number, it's very simple. Unsigned, sorry. When working the unsigned number, it's very simple here. Okay. Now think about that. If you want to store the decimal integer number 5 in an 8-bit memory location, right? Insert convert it to binary. You see, so this one. Now asking you the 8-bit memory, right? 8-bit memory. You only have the 3-bit right now. So to make it up to the 8-bit, you have to insert 50 to the left to make it for the 8-bit here. That's why it's this one here. Now this one, 938. You cannot store it in the 8-bit, right? Because you will have the overflow. You see, if you store in the 8-bit, you only have everything from 0 to 255 only. This one greater greater than 255. That's why for this one, you cannot store it in the 16-bit memory. You cannot store it in the 8-bit memory. But instead of that, you have to store it in the 16-bit memory location. So this one also, when you convert this one to binary, you have this one. Now you have to make it up to the 16 bits. You have to insert everything 0 on the left to make it up for the 16 bit here. Okay? That's all. That's all. Any question? Hello? Any question?
No.
Is this clear or not? Let me know. Anything, anytime not clear, let me know.
All right, sounds good.
Okay. Now we're talking about overflow. Right? Overflow, that means you cannot store it into the number bit location here. Right? So think about this one. If you want to store the integer 23 here in the 4-bit memory location, you remember that if you have the 4-bit memory location, 4-bit, so everything is 0, and that is minimum, and everything 1 is the maximum. This one you have 0, and this one you have 15. So it's only able to store everything from 0 to 15 in the 4-bit memory only. So if you want to store it in the 23, you got overflow. That means you don't have enough bit to store it here. So in order to do that, you have to store it in the 8-bit memory or more than that, right? Okay, so every you have this. If you have the 16-bit memory location, the 16-bit memory location, so actually you have the 2 raised to power of 16. You have about 55,000 here. Right? So if you want to store something here greater than this one, you also have the overflow. Okay, so here the range of the unsigned integer. You see, if you have 8 bits, everything is 0 minimum. Everything is 1 is maximum. You have 0 to 255. And you have 16 bit, you have 0 to 55,000. And you have 32 bit, you have about 4 billion here. That is the range of the IP address version 4. You have the 32 bit. And this one is a 64 here. Now, that is unsigned. I remember, but for unsigned, it's very simple. You just convert it normally from decimal to binary. So now we move to the sign and magnitude format. So what is the sign? Sign is everything negative or positive here, right? That is the sign, negative or positive. And what's the magnitude? Magnitude is how far you come from your position to the number 0. So we think about this one. Right? You have the number here, you have the negative possibility, negative infinity, and you have the positive infinity, and you have 0 here. Right? Think about this one. If you have -7 for this one, and you have the +7 for this one, right? They have the same magnitude because from 7 to 0, you have the 7. From -7 to 0, you have the 7 here. That is the magnitude. That means how far you come from your position to 0. And you have the sign here. You have this one is a negative and this one is positive. Right? So the sign and magnitude is one way to store the number for the negative, right? Integer number, right? The left mode bit here. Remember that the left mode bit is reserved to represent the sign. Right? And other bit other bit represents the magnitude or the absolute value. So the absolute value for the positive 7 is the 7, and the absolute value for negative 7 is also 7. That is something you have to remember. Now, remember, if you work in the sign and magnitude format, the last mode bit is reserved for the sign, and all other bit here is represent for the magnitude. Okay, now here's the thing. If you want to store the decimal number positive 23 here in the 8-bit memory location. So we just convert it here. The first thing you have to convert it. So 23, you can what do you have to? For 23, you convert it to the binary here, right? Binary. Now you see, you want to store it into the
Missing teenager Kate Wallace.
what is it? Hello?
Hello.
Anything is saying anything? Anyone saying anything? Any question from you?
Don't believe so.
Oh, I heard something. So if you don't say anything, please mute your microphone. Okay. So now I think here is this one. If you want to convert the 23 decimal to the 8 bit, sorry.
May I help you? Get me some nachos.
Hi.
Some fries. You know what's that?
You're watching movie?
Fries. Dumbass.
No.
Let me just get that for you. We don't have any nachos. Okay. Then how about some pizza?
Okay, so here, if you want to store the decimal integer number positive 23 in the 8-bit memory, this is the positive number, right? The first step is just convert. You just convert the number here, 23 to the binary here, right? You know that it's 8-bit memory, 8-bit memory. So the left mode bit is the reserved for the side. So you need the 7-bit, right? So you need the 7-bit. Right now you have 1, 2, 3, 4, 5, only 5 bits. So you have to make it up the 7-bit by insert 2 0 before that. Now you have 7-bit. And the last mode bit in the side, this one is a positive number. That is a 0. So if you have the positive number, the sign is 0. And if you have negative number, the sign is number 1 here. Right? So for this one, we'll convert it here. You see, this one, 0, that is a positive. And this one, you convert it, you have the 23. So you know this one, it is a positive 23 here. That's all. That is one working the sign and magnitude here. It makes sense? Very simple, right? It clear on? Let me know.
Yeah.
Okay. Now, if you want to store the decimal negative here, you just do the same, right? Forget about this one. Forget about this one. You convert the 19 here to the binary. You have this one. Right? You will have the 5-bit. You need to make it up for this one is 16 here. This is right. So you need the 15-bit for the value. That's why you have to insert 10. You have to insert 10 0 on the left to make it up for the 15. Right? That's one here. you have the 19. Now, the leftmost, it is a sign, and this one is a negative. That's why you put the number 1 here. So you see, this one negative, and everyone here, you convert it, you have 19. That's why you have negative 19 here. It's a 16-bit value stored here. Okay, it's very simple. Now, that is for the sign magnitude. Okay, but you have problem with the sign magnitude here. That is the problem of the when working zero number. When working zero number, you have 2 ways to do with a zero number here. That's the first thing here. Now, think about we working the positive zero here. Right? Positive zero in the 8-bit here. You see, you have zero, that's why you convert, you have zero here. So we need the 7-bit. That's why you insert the 6-bit here. 0, 1, 2, 3, 4, 5, 6. So now we have 7. It is number 0. Now, this one is positive. So the sign of positive here is 0. That's why you put 0 here. So when you convert this one is a positive 0. Now, if you're working with this one, what is this one here? What do you think? This one, number 1 here, it's a negative, right? So we have the sign negative here. And all of 0 here, you have 0. So this one, it is a negative 0. So we see, with the number 0, you have 2 ways to do that. This guy and this guy here. So it is way confusing for the computer here. So normally the computer is not working with the sign magnitude here. Because for the number 0, you have 2 ways to do that. It's not good at all. Right? You got this one or not?
Yeah.
Okay. That is problem of the sign magnitude. Because for the number 0, you have 2 ways to do that. Now, they move up to the another one. It is a 1 complement format. 1 complement format. So 1 complement format is that for the positive number, you do the same. You just reserve the positive number. The leftmost bit here is the number 0, and everything you just convert it normally from the decimal to binary. That's normally for the positive. But if you have negative here, if you have a negative number, you have to flip it. Number 0, you change it to number 1, and number 1, you change it to number 0. That's all. That is the 1 complement format. So now see how it works is this one. Okay, so here, if you're working with the negative 37 with 1 complement, right? Remember, for the if it's a positive, it's very simple. If you think about if it's a positive, it's very simple here. So you have 1, 2, 3, 4, 5, 6, right? You insert number 0 here to make it up 7-bit, and the leftmost bit it is a positive. You have 0 here. That is a positive 37. But in the case negative here, you convert everything here. You have the 0, 1, sorry, you have 1, 0, 0, 0, 1, 0, 1. If it's a negative number, you have to flip it. You have to convert everything from 0 to 1 and 1 to 0 here. As you see, you flip this one, 0. Flip this one, you have 1 here. You flip this one, you have 1 here. You flip this one, you have 0. And this one, you have 1. And this one, you have 0 here. You have to flip it. Okay. Sorry. For this one, you have to insert it. You have to insert the number 0 here. So to make it up 7-bit, right? So now you flip it. Everything you have number 0 here. You have number 1. Right? So now you flip 7-bit here. 0, 1, 0, 0, 1, 0, 1. You flip it 0 to 1. Right? 1 to 0, 0 to 1, 0 to 1, 1 to 0, 0 to 1, and 1 to 0 here. That is 7-bit. And the leftmost bit, it is a negative. That's why you insert number 1 here. So that's why you have negative 37 in the 1 complement. It is a 1, 1, 0, 1, 1, 0, 1, 0 here. So when you look into that, you know that this guy here is a negative. So you know that this one is a negative. in order to convert it back to the decimal, you have to flip it. So we have to flip this one. You have to convert it to 0 here, 1 here, 0, 0, 1, 0, 1. And when you convert this one, you have 37 here. That's why this guy, you have negative 37 here. Okay? It's clear now? Everything okay with you? Is it clear or not?
Yes, sir.
Yeah, it's very simple with this one, right? Okay. Okay, so here is a way you convert the one complement to the decimal. Remember that if it is a positive, very simple, right? If it's a positive, the left mode bit is 0. You just convert it normally. You don't have to do anything. If the left mode bit is the number 1, you know this one negative, negative. And every bit after that, you have to flip it 1 to 0 and 0 to 1. So also convert it to the decimal, and you add the sign is the negative. That's all. But again, so one complement also have problem with the 0 here. Now see, if you look on this one, if you look also on the S0 here, so what do you think? This one is a positive, right? Because the left mode bit here is 0. Left mode bit is 0. And when it's a positive, you just convert it normally. Don't do anything. So we convert 7 bit here 0. That's why you have the positive 0 here. Okay? What will happen is this one? You have the 8 bit of number 1. Again, if you look on this one, this is the sign. You know that this one is negative, right? And you know that if it is negative, you have to flip everything. And you have to flip everything here. So we have to flip this one to 0. And you convert it, this one is a negative 0. So we see, with the number 0, you have 2 ways to do that. This one and this one also. Again, it's not good for the computer at all. It's very, very confusing. So that's why in the computer, it cannot use sign magnitude because you have program of 20 here. One complement also cannot be used because again, you have the two policies. You have 2 ways to represent number 0. Right? That is the case of the sign magnitude and the one complement here. So in order to overcome the problem of the 0, they have to deal with the 2 complement here. So see, what is the 2 complement here? Okay, now it's a 2 complement integer. So to find the 2 complement of the x bit number, if the bit is positive, just convert decimal integer to binary and you finish. Remember, if it's positive, it's always the same. It's always the same. The same with the unsize, the same with the sign magnitude, the same with the 1 complement, and the same with the 2 complement. 2 complement here. It's always the same if the number is a positive. However, if number is a negative, you have convert the number to binary and find the 1 complement first. The first thing you have to find 1 complement first, right? And the third one, the second one, you add the number, add to the 1 complement of the number here. And if the result has an extra bit more than x bit, discard the left mode bit here. That's all. I remember. In order to find out the 2 complements, the first thing, if the number is negative, you have to convert everything to binary and find 1 complement. That's the first one. Add number 1 to the 1 complement. That's the second one. If the result is an extra bit, that means overflow here. You have to discard the left mode bit here. Now, let's see how it works. Okay, so the first thing you have to remember how to add the binary here. How to add binary here. All right. So you can see you have 0 and 1. Of course, you have 1 here, right? You have 1 and 1 here. Now what happened? You have 1 and 1. 1 and 1. What is it? 1 and 1. 1 and 1. You see that the binary you only have the 2 number. 0 and 1, right? So we cannot put the number 2 here. You cannot put number 2 here. So actually, the 1 and 1, you have to flip it back to 0, and you carry out 1 to the right here. And the same with the decimal, right? The same with the decimal here. You see, if you have the 5 plus 5, you have 0 and carry out 1 here. The same as this one. This one you cannot have the 5. You only have 1 and 0. Sorry? Hello? Hey. Any question from you?
Don't believe so.
Okay. So we say if you have 1 plus 1, you have 0 and carry out 1 here. Right? The same as this one. You have 0 and 1 and 0, you have 1. 0 and 1, you have 1 and 1 here. This one, 0 and 1, you have 1, 0, and this one here. Right? Again, if you have 1 and 1, you have 0, carry out 1. Right? So we see you have 0 and carry out 1 here. That's why you have 1. And this one here. Right? It makes sense? Do you think you have any problem with the adding here in the binary?
No.
Okay, right? Now, if you want to find the 2 complement of the 8-bit binary integer here, the first thing here, if it is a positive here, remember positive is always the same. That convert it normally, right? That convert it normally. So see, the positive 43 here, you convert it here, right? You need to store the 8-bit. You need to store the 8-bit binary. So we set x0 to the left. That's why you have this one. Remember, it is a positive number, but always the same. Sign magnitude and size 1 complement or 2 complement, always the same. Now, in the case of negative here, the first thing, convert 43 to the binary. That is the first step. That is the first step, you know. Now, you add 0 to the left to make it up for the 8-bit here. Add 0 to make it up for the 8-bit. Now, you're done. You're done with the negative 43 when you convert it to the binary here. Now, you have to figure out what's the 1 complement. The first step, the second step. Find out what is the 1 complement. So in order to find out what is the 1 complement, you have to flip everything. You have to flip everything. 0 to 1, 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 0, 1 to 0, and 1 to 0 here. Flip everything to figure out what is the 1 complement. So see, the first one. The first thing, convert to binary. And x0 on the left, to the left here. The second one, 1 complement. Find out what is the 1 complement. 1 complement. Now, when you find out what is the complement, the first one is that you have to find out the 2 complements by adding number 1 to this one. So you see, you adding number 1 here, 0 to 1, you have 1, and because this one here. That is 2 complements. That's all. So now, if you have number 1, 1, 0, 1, 0, 1, 0, 1, that is in the 2 complement here. If you want to convert it back to the decimal, the first thing you have to know that this guy here is a negative. This is a sign. This is a sign. So you have to work on the revert here. Now this one you have to add number 1 here. So in the case you figure out this one, you have to minus this one here. You have to minus this one. That's why you have 0, you have 0, you have 1, 0, 1, 0, 1 here. This one is 1 complement. You have to flip everything. That's why you have 0, you have 1, you have 0, you have 1, you have 0, and 1 here. And when you convert this one, you have the 43 here. So this one is a negative 43. That's all. That is working with the 2 complement. Okay. Anything? If you have any challenge with this one, let me know. Do you think you have a challenge? Anything with clear with this one or not?
I understand it.
Okay, that's good. Now we have to find out why the 2 complements solve the problem with 0 here. Okay, this one is integer overflow, right? Because you see, if you have the 8 bit, if you have 8 bit location, you have 1 bit for the size. So actually, you only have the 7 bit left. You only have 7 bit left to store for the magnitude. So 7 bit left, everything from 0 to 127 already. So that's why you have everything from negative 127 and go to the positive 127 for the 8 bit. That's why you cannot store this one in the 8 bit binary with the 2 complement here. You have to store it in the 16 bit. Okay, now why is the 2 complement solve the problem of 0 here? The thing is this one. Now, if you are the negative 0, you see that if you are negative 0, is it converted normally to the 8 bit here, right? So we have the bit number 0 here, and you add 7 bit on the left to make it up the 8 bit. That is the negative. That is positive here. Now, in the case of negative here, you see, you have to convert it to 8 bit here. Everything 0. The first step, the next step, figure out 1 complement. You flip everything. Flip everything here. Now, that is 1 complement. Now, in order to figure out the 2 complement, you have to add number 1 here. So see, 1 and 1, you have 0, carry out 1. Now carry out 1, you have 1 and 1, you have 0, carry out 1, and keep going. So we have 1 here, right? This one, it is the 1 overflow here on the left. So we see that if you have 1 extra bit, it always discard it. Right? So when I see you discard this one and you come back to the order of 0, exactly the same with the positive here. So we see even if it's a positive or negative, when you're working with 2 complement, you only have the same thing. It's order of 0 here. It makes sense? Hello?
Yeah.
Right? So you see, when you add them together, remember that when working the 2 complement, if you have the 1 extra bit, you have to discard it here. That's one. Okay, so that's why the computer normally working with the 2 complement. 1 complement is a 2 problem is a 0. Sign magnitude also 2 way to represent 0. Not work. Okay, now we move to the floating point representation. Integer number, you know that, right? You have unsize, you have the sign magnitude, you have 1 complement, and you have 2 complement here. Now working with floating point representation. So all floating point number has the both integer part and the fractional part here. Right? Even that if the fractional part is 0. So see, the number 6 here is integer, but the 6.0 is not integer, it's a floating point because it has the integer part and it has fractional part here. Right? So to represent a floating point number in binary, you have to break it down into 2 parts. Sorry, in 3 parts here. The first one is size, the same. If it's positive, you have number 0, and it's negative, you have number 1 here. And the second one is a whole number, it's an integer part. And the third one is a fractional part here. So we can think about this one. You break it down, the number here, 16.75. All right, so we have this one. It is a side part. This one is the integer part. And this one is a fractional part here. Right? So in order to working with the floating point, you have to break it down in 3 parts here. The side, the whole number, and the fractional part here. Sorry, for some reason I forgot my glasses, so my eyes dry. It's quite dry now. Okay. Okay, now the integer part is the same, right? It's a specific part set aside to denote for the side, You only have the leftmost bit to represent the sign, and to convert the integer part to binary, it just simply converts the way you convert a positive number to the binary. Right? You just do it normally. You just convert it to the normally. So the integer part of floating point number. So integer part of floating point number is separate from the fractional part. The dot here. It's a dot. In order to separate between the integer part and fractional part, you use the dot or period here. You see this one here, right? So we have negative 16.58 here. This is a dot to separate between the integer part and fractional part here. Right? And the point is, in fact, it's a binary point. It does the same thing as the decimal point. It's a decimal system here. Now, let's see how we working with this one. Okay. What? Okay. Now remember, if you remember about decimal system, if you think about decimal system, right? In order to do working with, say, you have the 16.58 here. So what is it? This actually you have the 10. No, let me. This not this one. Think about you have the 48.57 here. Right? So for this one here, you have to break it down. You have a 4 of 10, right? You have 4 of 10, and you have 8 here. Right? And this one, what is it? You have 5 times 10 negative 1, and plus 5 times 10 negative 2 here. This one 8 times 10 negative 0. And you see, you have 40, you have 8, and you have this one, you have 0.5, and this one they have 0.057 here. So when you add them up together, you have 48.57. Right? So see, the position value is always the same. I see this one is a 1 column. This one is 10 column. This one is 1 over 10. This one is 1 over 100 column. Right? The same. It's all the same. That's why you see this one 5 over 10, and this one, sorry, this one 7 over 100. It working the same, right? It working the same. You only have the position here. You only have the column and the position. This one is a 1 column. This one is a 10 column. This one is a 100 column. And this one here, 1 over 10 column. And this one, 1 over 100 column. Or you can change it. You can have 10 raised to 0, 10 raised to 1, 10 raised to 2, and this one 10 raised to negative 1, and 10 raised to negative 2 here. That is the way working with the position value of the column, right? It makes sense. So you see, if you have 48, 57 here, actually you have the 4 of 10. You have 4 of 10. You have the 8 of number 1. You have 5 over 10, and you have the 7 over 100 here. That is when working with the decimal system, right? Now, the binary is working always the same. It also always the same. Right? In the case of the binary, you see, you also have the value here, right? You also have you have the column here. So if you have this one, you have the number 1. Here, this one you have number 1, and this one you have number 2 and 4 and so on here, because you have 2 raised to power of 0, 2 raised to power of 1, and 2 raised to power of 2. And this one you see, this one you have 2 raised to power of negative 1. This one is 2 raised to the power of negative 2, and this one 2 raised to the power of negative 3, and so on here. Now see, if you have the 2 raised to negative 1, that means 1 over 2. You have 1 over 2 here. You have 0.5. This one, 2 raised to power negative 2, that means 1 over 4. 1 over 4 here. You have 1 over 4. You have 0.25 here. This one, 2 raised to negative 3, that means 1 over 8. You have this one, and so on here, and so on. That is the fractional part. Fractional part. All right. So now how it works is this when you convert it here. Okay. So we see if you want to convert for fractional part, you see the first column here, it's a 0.5, the second one 0.25, 0.125, and so on here. All right. So now see what happened with this one. Now think about if you want to convert here. If you want to convert 0.4 to the 6-bit binary number here. All right. So again, the rule is always the same. You only have to working from the left to the right. And the left to the right, you see 0.4 less than 0.5. That's why you put 0 here. All right. Now we move to the right. In order to make it 0.4, you need 0.25 here, right? So when you need 0.25, you put the number 1 here. Or when 0.4 greater than 0.25, you need number 1. So now you already have the 0.25, you have to minus here. 0.4 minus 0.25, you have 0.15 left. Right? Now, again, you move to the right. In order to make it up for the 0.15, you need 0.125 here, right? You need it, that's why I put number 1 here. So when you need it, you have 0.025 left. 0.025 left, less than this one. That's why you put number 0 here. Right? And move on. 0.025 left, less than this one. You put 0 here. And 0.025 here, greater than this one, you put number 1 here. You see, you only need 6-bit binary number. So you have 1, you have 2, you have 3, you have 4, you have 5, you have 6 here. So if you have if you have point here, 0, 1, 1, 0, 0, 1. It is the way you convert it to the number 0.4. That's all. It makes sense? Hello?
Yeah, I get it.
Yeah. So it works with the same with the decimal. Yeah. In the decimal, you have the 10 raised to -1, 10 raised to -2, and 10 raised to -3. That means you have 1/10, 1/100, and 1/1000. But this one is a binary. That's why you have 1/2, 1/4, and 1/8, and so on. Okay? Okay, now remember that you have the 3 parts on the floating point. You have size, you have integer part, and you have fractional part here. Right? So now see, if you want to convert the number here, if you want to convert the number 75.804 to binary, now bracket here, that is a positive, right? Now convert this one 75 to the binary here, right? You have this one here, right? You have this one. This one it is an integer part, right? This one is integer part here. You don't have the side. You don't have this side here, right? That's why you have the side. So this one integer part. Now you have 0.84, right? 0.84. Now you see, in order to make it up to 0.84, you need 0.5. That's why you put number 1 here. Now when it's 0.5, you have this one left. You move to the right. Greater than here, put number 1 here. You have this left. You have this left here. Now this left than, put 0. This one left than, put 0 here. You need what is it? You need a 4-bit. You need a 4-bit here. So this one to make it up for the 0.804. That's all. That's the way you convert it into floating point here. It's the way computers working on this one. What? Okay, so I think that's all for today. We do everything with the conversion number here. Remember, you have something, right? You have the binary, you have decimal, you have hexadecimal notation. For the integer number, you have unsigned number, you have sign and magnitude, you have 1 complement, you have 2 complement, and you also know how to convert the floating point here to the binary. Let's see. Let's see what you have left. Actually, you already go this one. You have the module 3 here. Okay, now if you look at this one, what do you think? What is the base number system here? What is the base? If you have the 45 raised to 5, what is the base here?
10,000.
So why 10,000?
Oh, wait, sorry.
Remember, you have the two components. You have the base and the exponent here. Alright? So what is the base? For this one, what is the base here? 45 or 5?
45.
Yeah, 45 is the base for this one. What do you have for this one?
That's 1.
Yeah, right. Remember, every non-zero number, when you raise to 0, you always have 1. How many digits you have in binary system?
2, wouldn't it?
2 only. Right? 0 and 1, 2 only. Okay. Now, a very long binary number, maybe convert to notation to make it easier to read. What do you think? Convert to what notation?
Hexadecimal.
Yeah. Remember that when working with hexadecimal notation, you group every 4 bit together from the right to the left, every 4 bit together. Right? So we think about this one here. Alright, where 4 bits, this one you convert, you have number 2. This one number 2, and this one you have 14 here, and so on. This one is the hexa notation here. How many digits on the hexadecimal system? How many digits? What do you think?
16.
Yeah, 16. Everything from 0 to 9, A, B, C, D, E, F. To the binary. Very simple. You can use a calculator if you want. I don't force you to have to do it manually. You can use a calculator. The condition nowhere occur when you try to store an integer that is bigger than the maximum allowed of the number of bits you have. What is it? What is it?
Overflow.
Sorry?
Overflow.
Yeah, overflow, right? So think about if you want to store, if you have the 8 bit here, if you have 8 bits, so the minimum is everything 0, you convert it to 0, and the maximum is everything number 1, you convert it to 2.5 here. But if you want to store number 300 here in the 8 bit, you cannot do it. That'd be great to start to provide. In that case, it's the overflow. Okay, what do you think about this one? What is this? Is a 1 complement or 2 complement here? What do you think?
Is it the ones complement?
Yeah, this one is not convert, it's not flip it away, right? Remember that for two complement, you flip it and you have to add to number one also. This one you don't add a number one. So that's why you have one complement here. Okay, in binary, adding 1 to the 1 result in what do you have?
0.
Yeah, right. Because you have to come back to 0 and carry 1. Alright, number differ from integer because. What do you think? What is it? What is it? Floating point. Right? For floating point number, you have the both of integer part and the fractional part. Floating number. Oh, this one very simple, right? You know that this one is a 4 and this one is a 2. Add them up together, you have 6. One is a binary converted by computer calculator. 4-bit can present in the decimal number. 4-bit can represent the decimal number. What do you think? Yes or no? Yes or no? Yes or no?
I would say yes.
Yeah. So for the decimal number, how many value you have? You have 10, right? You have the 10. You have 10 value, everything from 0 to 9. But if you have 4-bit, in total we have 2 raised to power 4, you have 60 value. So it's enough, right? A group of 8 binary digits is a what? What do you think? Byte, right? Every 8 bits is 1 byte. Oh, okay, now, what do you think? How about this one? I think this one is not good. This one is not good. This one actually you cannot do it. It will have overflow here because you have the 8 bit. That means you have everything from negative to the positive 8 only. So I think I have to modify this one. I had to keep editing this one. Question. I changed the APT. Sorry, yeah. APT. Oh, that's why I have to change everything. Okay, I will change it later. Okay, anyway, skip this one. This one is not good. You cannot convert it. You have overflow. This one also, it hexadecimal, very simple. What is the value of 2? What's the value of 2 here? What do you think? What's the decimal value of 2? See here, what is it?
12.
See the 12? How about 8?
10.
Say 10, but it's a 16 column, right? So actually you have to 10 to the 16, you have 160 for this one.
Oh, right.
And this one, how about, what is the column value for this one?
That'd be hundreds, right?
Now we see, now, let's see, you have the column here, right? So see, This one is the first column, right? So we have the 16 raised to power 0, 16 raised to power 1, 16 raised to power 2, 16 raised to power 3, and so on. You have 1 here, you have 16 here, you have 256. Right? This one is the column 256. And you have number 2, that's why number 2 here, you have 512 here. That's all. It makes sense? It clear? So this one converted normally. This one also. This one very good also. What is it? If you convert 135, but this one is the base 8 here. Actually, the number can be in any base. Can be by 2, by 3, by 4, by whatever. So now, if you have the base 8 here, base 8 that you have to break it down in the column as well, right? You have to break it down in the column. This one, 8 to raise to 0, 8 to raise to 1, 8 raised to 2, and 8 raised to 3 here. Right? So see, 8 raised to 1, 8 raised to 1 is 8. 8 times 8 is 64. Right? 8 times 8 is 64. So we see you have 1 here, you have 3 here, you have 5 here. So we have to times 1 to 64, 3 times 8, and 5 times 1. You add them up together. It makes sense? Hello?
Yeah.
Yeah, because here the rate is by x. By x, that's why you have the 8 here. 8 here. That's all. Actually, you can do with any base. Number 5, number 6, whatever it is. Why is the same? I think you already have the base here, right? Group of 8 here. Yeah. Oh, I don't know. Anyway. Okay, so I think that's all for today. And I'll see you guys on Thursday. And I will make an announcement and asking if any one of you come to campus, I will come to campus, if any one of you. But if you not come to campus, I'll stay at home and working with my support here. It's the same. I can write on my screen. It's okay.
All right. Sounds good.
Okay. So bye guys. See you on Thursday. Bye bye.